Hello students, welcome to Unacademy. Good evening all. Unacademy provides you a great opportunity to meet legends and top educators in the engineering studies, engineering education. So that will help you, the students who are in the remote places. Now, mostly due to lockdown, students are located at their villages. They are in a situation what to do and how the time is going to be getting passed. But Unacademy provided you the best opportunity to interact the students along with the top educators in the field by providing special free classes on YouTube as well as Unacademy platform. So generally free classes may be one or two provided by any coaching center, but not several number of classes. But here Unacademy we have several number of free special classes. Every day one class, monthly 30 hours of subject you are going to learn for free. Just free online classes will give you around 50 to 60% of syllabus to solve numericals in GATE and ESE. So utilize this opportunity. Good evening all. CTAX Consultancy, Mayank, Dahia, Manoj, good evening. So utilize the opportunity provided by Unacademy. Work for the best. Learn the subject. Spread the knowledge to everyone. And make more number of your friends to be benefited by these free special classes. Inform them Unacademy is giving this opportunity for free classes. So we'll go ahead into the subject. Air pollution part 6. Till now we have completed 5 days, 5 sessions related to air pollution. Good evening Banu Prakash. And in ESC general studies, this air pollution is an important topic which is under energy and environment. And in GATE and IS, for civil engineering students, air pollution you have 2 question compulsory, very important topic. So we have completed 5 parts of air pollution, entering into 6th part. We have completed air pollution introduction, causes and types, pollutants, types and their effects, concentration unit conversions, and meteorological factors affecting air pollution. We are in the middle of this topic, which include different types of plume behavior. Both are interrelated with one another, both topics. 50% of topic yesterday we have completed related to meteorological factors affecting air pollution and types of plume behavior. Bala Saheb, Venkat, Negi, good evening all of you. So now we are entering into the meteorological factors affecting air pollution. So what we have studied yesterday, just a brief 2 to 3 minutes discussion we are having. Yesterday we have studied about different types of environmental lapse rate. In that different types of environmental lapse rate, the first one, this is the first one, super adiabatic lapse rate, where we can consider dt by dz greater than minus 10 degrees Celsius per kilometer. What it shows? It shows a looping plume behavior. This plume behavior shown by this is looping plume behavior. And second one, this is said to be sub-adiabatic lapse rate, showing coning plume behavior, where we'll consider dt by dz less than minus 10 degrees Celsius per kilometer. The plume masses form like a cone shaped structure near to the chimney, They may fall down at any time. Near to the stack, plume masses is accumulated. Here plume masses have been taken far away, far away, far away, long journey, along with the spread, along with they are going to be spread, huge mass spread in the atmosphere. The third one, neutral lapse rate, where we consider dt by dz exactly equal to minus 10 degrees Celsius per kilometer. Pollutant mass will travel vertically high above the atmosphere. Vertical plume behavior. It is going on in all the three conditions. In this all the three conditions we can write down here. Super adiabatic lapse rate, subadiabatic lapse rate, and neutral. In all the three conditions, temperature is inversely proportional to altitude. Temperature is inversely proportional to altitude. In all the three conditions. Means altitude increases, temperature decreases. In superadiabatic, subadiabatic, as well as in the neutral lapse rate. Then we have the fourth one, inversion. What happened in inversion? Fourth one, temperature directly proportional to altitude. Increase of altitude increases temperature. This is the condition. Now all the kinds of three, superadiabatic, subadiabatic and neutral lapse rates, temperature and altitude are inversely proportional to one another. In inversion, it is changing, temperature directly proportional to altitude. With increase of altitude, temperature increases. And this is the fanning plume behavior due to two inversion layers. Pollutant mass not falling down, not going away, both does not occur. Exactly horizontally, linearly it is going to travel, lateral traveling, horizontal traveling, that was shown, and the plume behavior we call it as a fanning plume. So we have discussed four types of lapse rates: superadiabatic lapse rate, subadiabatic lapse rate, neutral lapse rate, inversion. How many changes of temperatures will be happen in the four? Only one change. Na? From ground level throughout the atmosphere, whatever modification it is going to be happen, only decrease with respect to first. From ground level till atmospheric zone, tropospheric zone, continuous increase of temperature with respect to inversion. So one change in all the cases. Now all these cases will conclude, we will conclude one change of temperature. The change may either, it may decrease in first three cases, or it may increase in the next case, inversion. The first three cases decrease, na? In the inversion case increase, but only happened means either increase only happened means or decrease only happened, but not increase and decrease both, only one change. Now we are entering into two change condition. Now we are entering into two change condition, what we call first one, lofting plume behavior. Lofting plume behavior. What is going on in lofting plume behavior? In lofting plume behavior, very important, remember, inversion below the stack. inversion below the stack. Super adiabatic lapse rate. Super adiabatic lapse rate, where it occurs? Above the stack. That means temperature fluctuation modification are 2. The vertical temperature profile is not going to show single modification. The vertical temperature profile is going to show 2 modification. I will clearly explain you. Consider this is the stack of the chimney. Consider this is the stack of the chimney. Then up to the stack height, what is going to happen? From ground level till the stack height, from here to here, inversion, clearly written, below the stack. And above stack, what is going to happen? Super adiabatic lapse rate. It is the meaning of inversion below stack. From this stack means from ground level till stack height. Consider this is ground level. From ground level till stack height, temperature goes on increasing. Temperature increases with altitude. After reaching stack height, temperature is going to fall down, increase of altitude. Means ground level to stack height, temperature directly proportional to altitude. Above stack height, temperature inversely proportional to altitude. Got the point? From ground level to stack height, temperature directly proportional, so that it is goes on increasing. Above stack height, super ALR. Super ALR means temperature inversely proportional altitude. We have written clearly, na? So super ALR, sub ALR, neutral. What is temperature inversely proportional to altitude? So above stack temperature is inversely proportional. Below stack temperature is directly proportional. So I will give a graph. So we are taking Z altitude on y-axis. Altitude on y-axis, temperature on x-axis we have taken. And very important, we need to mark here. This is 1 kilometer. And remember, this is stack height. Stack is located from ground level to this point. Okay. For your understanding only, I have drawn stack height. In the exam, in the paper, in the question, in the textbooks, materials, never stack height is given. For your easy understanding, I have taken advantage, I have drawn stack height. Okay. Now when we take dry ALR, what happened dry ALR? From ground level at this point, take 40 degrees. So this is 30 degrees according to dry ALR. Now what we are going to plot? Lofting, behavior of lofting plume. Clear? Behavior of lofting plume. From ground level to stack, what is happening? Temperature goes on increasing. From ground level to stack, temperature rise is going to take place up to this. This is happening up to this. Ground level to stack height, inversion is going to take place. Temperature goes on increasing. Ground level to stack height, what is happening? Inversion. Temperature increases. So it moves right. After reaching stack, what is occurring? After reaching stack, what is occurring? Super adiabatic lapse rate. So after reaching stack, it is moving like this. Super adiabatic lapse rate means temperature fall down. So it is moving downward, moving leftward, moving leftward. Temperature increases. Initially it is at this point. Temperature increases means it goes this direction. Temperature decreases, it go left. Temperature increase, right. So initially from ground level to stack height, temperature increases. Stack height to up to whatever altitude, it goes on, temperature goes on decreasing. Super adiabatic lapse rate. Then very important, this is the diagram. So the flow mass, plume mass is flowing continuously, not allowed to fall down. Which is not allowed to fall down? Inversion layer is there. This inversion layer not allowed to fall down. It may spread in the atmosphere because this is super adiabatic lapse rate. It may spread in the atmosphere but not falling down. See here, mass is spreading but not coming down. Is it falling down here? Mass is not falling down because top end spread, huge spread because of super ALR, but bottom end inversion layer, if it is trying to fall down, what the inversion layer? Inversion layer will push upward direction. So inversion layer does not allow pollutant mass to fall down. That makes spread here. Super ALR is always showing high dispersion and dilution. Clearly we have explained. Super ALR is going to show high dispersion and dilution. Because of that reason, in the upper atmosphere it is going to spread more. So spread is going to be happen due to super ALR. So it is going on upward direction only, not coming downward direction. That is lofting plume. Anything to explain in this super ALR and inversion related to lofting? Super ALR at the top, inversion at the bottom. Plume mass does not fall down below stack. See here, this is stack height. Plume mass is not going to fall down below stack. Na? See here also, plume mass does not going to fall down below stack. Plume mass go high above the stack. So such condition we call it as a lofting. The important point you need to remember, inversion below the stack, super adiabatic lapse rate above the stack. Remember this graph also. Okay. We are moving on. Next one, fumigating plume behavior. Exactly opposite. Exactly opposite to what is the previous one? Lofting. Exactly opposite to lofting. In lofting, inversion is below stack. In fumigating, inversion is above stack, and super adiabatic lapse rate is below stack. It is simply like a mirror image, downward mirror image. Super adiabatic lapse rate is below stack, inversion is above stack. Exactly opposite, downward mirror image of what we have discussed previously. Consider again, this is ground level, stack. Now what is happening from ground level to stack? From ground level to stack, super adiabatic lapse rate. Meaning of super adiabatic lapse rate is temperature goes on decreasing. But above stack, what is there above stack? Inversion. Above stack, what is going on? Inversion. Inversion, meaning of inversion, temperature increases. So from ground level up to stack height, with increase of altitude, temperature decreases. From stack height to throughout the troposphere, temperature goes on increasing. Clear? From ground level to up to stack height, temperature decreases. Above stack height, temperature goes on increasing. That is said to be fumigating. I will show the diagram. See what is going on here. Yes, Manoj, it is possible practically, especially winter season, evening time, that is going to be happen possibly, Manoj. Fumigating. What is this layer we call here? This is inversion layer. This is inversion layer, na? Where the mass is falling down? Mass is falling down near to ground level, because below inversion layer, super ALR. It is meaning of super ALR. Super ALR means high dispersion and high dilution. In which direction they are dispersing and diluting? Downward direction. Why downward direction? Because top layer is inversion. So this top layer will suppress. It does not allow to go high above. It does not allow to go high above. It suppresses. This top inversion layer make plume mass to go suppress downward direction and showing super ALR. So where this mass is releasing? Very important point. Pollutant mass or plume. Pollutant mass or plume. Where it is released? Released near to surface, ground level. Pollutant mass or plume releases near to surface. And this point is very important. The plume behavior or the kind of plume which allows pollutant to be released into ground level. The type of plume which releases pollutant to near to surface, that is said to be fumigating plume behavior, falling down near to ground level. Is it clear? Shall we move on? Yes, we need to plot the graph. We are going to plot the graph here. Same altitude on y-axis, temperature on x-axis, this is a stack, and this is 1 kilometer. Now, as like previous, first we are going to draw for ALR. This is adiabatic lapse rate. In every graph, remember this point, the line is a standard reference line of temperature fall down shown with respect to dry adiabatic lapse rate. In each graph you need to mention it. Without it you are not going to plot the graph. Okay? Remember that point. Now, in which direction it is moving? From ground level to stack. Very important. From ground level to stack. What is happening? Below stack, super adiabatic lapse rate. So, from ground level to stack, it move on like this, because here is going to occur super ALR, temperature decline. Temperature decline means curve shift to left. Temperature decline, curve shift to left. Up to what point? Up to what point curve shift to left? till stack height. After that, inversion. What happened after that? Inversion. Inversion means temperature increases. Inversion. Inversion. Temperature increases. Curve shift towards right, na? Curve shift towards right. In the first case, curve shift towards left. From ground level to stack, curve shift toward left. And after that, curve shift towards right. This is the graph related to fumigating plume behavior. Got it? Neeraj Nani answered left. Okay. So anything to explain here in this regarding fumigating plume? What the points you need to remember? First one, inversion above the stack, superadiabatic lapse rate below the stack. 2, temperature modifications in the vertical profile. Then the pollutant mass released near to the ground level. So high pollution happened due to fumigating plume. Highest air pollution caused due to fumigating plume. And this is the diagram. You need to remember, I told you yesterday also, you need to remember the diagrams also, because match the following questions are provided to you. Got it? Good. We'll go for the last type of plume behavior. It is a trapping plume behavior. Trapping plume behavior. What is going on in trapping? In trapping plume behavior, inversion above as well as below the stack. Inversion is going to be occurred above as well as below the stack. So consider this is the stack. A layer of inversion is present in the middle of the stack and another layer of inversion is present above the stack. This is inversion layer 1 and this is inversion layer 2. And what is going to do this inversion layer 1 and 2? Inversion layer 1 does not allow pollutant mass to fall down. Does not allow pollutant mass to fall down. And also inversion layer 2 does not allow pollutant mass to raise up. Means there is a opening, big opening. Then pollutant mass is not going downward, not allowing upward. So both direction, downward flow and upward flow of pollutant mass is not allowed. Then what is the difference here? Because the same we discussed here in fanning. Na? In fanning also same thing. Inversion layer 1 not allowing here and not allowing here. The difference here is this width. The width goes on more in trapping. Second one, here pollutant particles are closely packed. Dispersion and dilution in the fanning is very less. But very important point related to trapping I am going to reveal. Very important point. In between two layers, in between two inversion layers, what is present in between? In between two inversion layers, what is there? Lapse. Especially lapse as super adiabatic lapse rate. This is very important point. Difference between fanning and trapping. Difference between fanning and trapping. Fanning is a narrow layer Small passageway, through this small passageway pollutant mass will go. Trapping is bigger, because I will tell you, I am writing regarding fanning here. What is happening in fanning is two inversion layers. There also in fanning also two inversion layers. Where the two inversion layers are formed? One just above stack, one just above stack, another one attached to the stack. Two layers of inversion, same like trapping and fanning, but the distance between two layers is varying. The distance between two layers is varying. Consider this is the stack. Layer 1 is formed here and layer 2 is formed here. Consider this is X1. This X1 is related to fanning. Clear? The layers are very close to one another. Pollutant mass will travel like this only. This is X1. Inversion layer 2, inversion layer 1. The same when we discuss with respect to this. What is the height difference between inversion layer 1 and layer 2? X2. Which is bigger? X2 is bigger, na? X2 is greater than X1. X2 is related to trapping. X2 is related to trapping. X1 is related to fanning. That is the basic difference between trapping and fanning. The layer pollutant mass is traveling in a small narrow passageway. Here the pollutant mass is traveling through bigger passageway. This bigger passageway X2 is bigger, and very important, here there is no possibility in X1, there is no possibility of dispersion at all. Here super adiabatic lapse rate is going to take place. What happened if super adiabatic lapse rate is going to occur? Dispersion, spread of pollutant. So inversion happened above and below the stack. Above and below the stack inversion happened. In between the inversion layer, super adiabatic lapse rate. Due to that super adiabatic lapse rate, more huge spread, dispersion and dilution of pollutants is going to occur very highly. What the point? Difference between fanning and trapping is very important. Got it? Now, how many temperature fluctuations occur? How many temperature fluctuations occurred? First we have studied one temperature change. Superadiabatic, subadiabatic, neutral lapse rate. From ground level throughout troposphere temperature goes on decreasing. Inversion, from ground level throughout troposphere temperature goes on increasing, one change. Then in a lofting plume, two changes. Na? From ground level to stack height temperature increases. Stack height to throughout atmosphere temperature decreases. Lofting, two variation. Same mirror image happening, fumigating. Ground level to stack height temperature decreases. Above stack height temperature increases. Two modifications are going to happen. So one modification, temperature profile modification, one happen. Super, sub and neutral lapse rate along with inversion. Inversion means fanning plume of inversion. In lofting and fumigating plume, how many variation? From ground level to stack height, one variation. From stack height to up to a troposphere, second variation. Two temperature fluctuation. Now how many are going to happen in trapping? So this is the trapping diagram. From ground level to stack height, inversion layer 1, I1, this is inversion. And above stack inversion layer 2, means above stack also again there is a inversion. pollutant mass is going to be moving, spread, mixed, dispersed and diluted within these zones I1 to I2. What is in between? In between super adiabatic lapse rate. In between super adiabatic lapse rate. Now how many changes will you shall we show here? Any one of you answer, how many temperature variations shall we show here? Subhadeep. Okay. So from ground level, this is ground level, this is the middle of the stack. What is going on? Inversion. So this is a line showing adiabatic lapse rate. Remember, this is the line showing adiabatic lapse rate. From ground level to middle of the stack. From ground level to middle of the stack, what happened? Temperature increases because inversion is there. First change. And after that, from this inversion layer to inversion layer 2, inversion layer 1 to inversion layer 2, what is going on? Super adiabatic lapse rate, temperature decreases. This is change 2. Above that, what is there? Again inversion, temperature increases, change 3. How many temperature fluctuations are there? 3 different altitude ranges, 3 different fluctuations of temperature. I will show by plotting diagram. By plotting the graph, that is easy for you to understand. Temperature on x-axis we have taken. Altitude in kilometer on a y-axis we are considering. We are going to mark, this is 1 kilometer and take this is the height of the stack. Stack is located here. Good to nearest, 3 variations you have answered. Now as regular, this is the regular flow as per adiabatic lapse rate, regular model, reference line. Now what is the first going on? What is the first change going to happen? From ground level to some middle of the stack. What is going on? Inversion. So temperature increases. Temperature increases means which direction it moves? Temperature increases means it move on right side. It move on right side up to some distance. Move on right side up to some distance. Why right side? Because this is happening inversion. It is condition of inversion. Temperature increases. Temperature increases. Now second condition. Up to some height above the stack, temperature goes on decreasing. Why up to some height temperature goes on decreasing? Because super adiabatic lapse rate, super ALR is there. After that height, again what happened? Temperature increases. After that height, temperature goes on increasing because again there is a inversion. Again there is a inversion. So how many changes we have shown here? Change 1, inversion from ground level to up to certain height of the stack. Inversion 1, temperature increases. After certain height of the stack till up to somehow above the stack, super adiabatic lapse rate change to super adiabatic lapse rate change to temperature fall down left. It move towards left. Above the stack, then inversion change 3, again temperature increases. So this is the model of the curve we are forming. By what kind of behavior this one? By trapping plume behavior. Trapping plume behavior is having this kind of graph. Three different fluctuations, three temperature fluctuations in the vertical temperature profile of the atmosphere. Got it? In the vertical temperature profile of the atmosphere, first one change by superadiabatic, subadiabatic, neutral lapse rate and fanning plume of inversion. Next, two changes, up to stack one change, above stack another change with respect to lofting and fumigating plume. With respect to lofting and fumigating plume of inversion. The last one, three temperature fluctuations from ground level to middle of the stack, from middle of the stack to above stack to throughout troposphere. Three temperature fluctuations in the vertical temperature profile related to trapping plume of inversion. So this is complete picture related to plume behavior of pollutant mass in the atmosphere. So we have finished plume behavior. If any doubts, you can post it, I will answer. So these are what graphs as well as plume behaviors we have provided. We are discussing about, till now what we have discussed is, these are the different kinds of temperature fluctuations and graphs. So first one we discussed, super adiabatic lapse rate. Super adiabatic, dotted line, remember dotted line is always ALR. So super adiabatic lapse rate shift left of ALR, and this is looping plume behavior. Atmosphere highly unstable, strong instability. Atmosphere is highly unstable, strong instability. This is the first one, super adiabatic lapse rate. Second one, this one, second one, sub-adiabatic lapse rate. First one, this is ALR, and this is super ALR, and this is sub-ALR. Adiabatic lapse rate middle, left super, right sub, and near to neutral stability. That means temperature is not unstable, near to neutral stability. What behavior? Plume behavior is coning plume behavior. Third one, neutral plume, temperature travels vertical upward direction. Same like ALR it is going to happen. It is not going to fluctuate anything, same like ALR it is going to happen. Then fourth one, what we discussed about actual inversion, fanning, extreme inversion condition, surface inversion condition, extreme inversion condition, fanning. Masses are moving like this. So exactly opposite na. This is ALR line and this is inversion line, exactly opposite condition. Then after fanning, what we have? Lofting. Pollutant mass not falling below. From ground level to stack height, temperature increases. After stack height, temperature decreases. Temperature increases from ground level to stack height because of inversion. Above stack height, temperature decreases because of super adiabatic lapse rate. This is a fifth one. Aloft inversion. Aloft inversion means falling down near to ground level. Opposite to loft. Loft is pushing upward. Aloft, pushing downward. Exactly opposite. Aloft, opposite to loft, falling downward near to ground level. From ground level to stack height, temperature fall down, super ALR. After stack height, temperature increases, inversion. This is sixth one related to fumigation. Last one, clearly shown 3 changes. From ground level to middle of the stack, inversion, temperature increases, inversion, temperature increases. From middle of the stack to up to certain height, super ALR, temperature decreases. Then above the stack height, temperature increases because again inversion. This is the last condition we have, what we call it as a trapping. Inversion below and above the stack, lapse, super adiabatic lapse rate in between. So this is just a synopsis model showing curves as well as plume behaviors in the picture. Now we are discussing other factors. Other factors means other than temperature, remaining factors influencing. First factor is temperature. We discussed in detail related to temperature. The second one, wind velocity. Wind velocity. Air in motion, moving air. That moving air is said to be wind. If suddenly wind masses are coming from the chimney, pollutants are released, suddenly fresh air mass is moving, then what the air mass will take? The air mass will take away pollutants far away. So the dispersion and dilution is more. So remember, wind velocity directly proportional to dispersion and dilution. It causes high dispersion and high dilution. Continuous flow of air masses are going on. Shall we say atmosphere is stable? No. Atmosphere is unstable. So it is inversely proportional to stability of atmosphere. It is inversely proportional to stability of atmosphere. So that ultimately less air pollution. Wind velocity is high, air pollution is less because atmosphere is unstable. Clear? Atmosphere is unstable, so air pollution is less. Then estimation or measurement of wind velocity. Wind velocity is measured using the instrument anemometer. Anemometer is the instrument used to measure wind velocity. Then we apply a law which is called 1/7 law. We are going to apply a law, 1/7 law. First we are measuring wind velocity at 0 kilometer, Z0. Altitude Z0 is wind velocity at 0 kilometer and velocity is V0. We need velocity at altitude Z1. Velocity at altitude Z1 is V1. Velocity at ground level Z0 is V0. Then how will we determine V1? We can't fly high above the atmosphere. Na? We are not moving high and go there and we are not measuring wind velocity. Na? So using 1/7 law, what we can write down? V1 by V0 is equal to Z1 by Z0 whole power 1/7. This is called 1/7 law. V1 by V0 is equal to Z1 by Z0 whole power 1 by 7. So we'll estimate using this formula, we'll estimate V1. V1 is equal to V0 into Z1 by Z0 whole power 1 by 7. V1 is equal to V0 into Z1 by Z0 whole power 1 by 7. So velocity at altitude Z1 is estimated. Then direction of wind. How direction of wind is measured? Direction of wind is measured using wind vane. Direction of wind is measured using wind vane. And wind distribution at a location. These are important theoretical questions, you remember it very well. Wind distribution at a location in atmosphere, at a particular region in the atmosphere, that is picturized diagrammatically by using wind rosette diagram. Wind velocity estimated using anemometer. Direction of wind travel is known using wind vane. At a particular place, distribution of wind for a specific time is known by using wind rose diagram. Then third factor. First factor temperature completed. Second factor wind velocity completed. Third factor will take pressure. Atmosphere. Pressure in the atmosphere. So pressure in the atmosphere will consider first high pressure region. What we call high pressurized air. High pressure air we consider it as anticyclone. High pressure air will conclude as anticyclone. Under these circumstances, anticyclone means, again we'll say unstable atmosphere. Anticyclone means anticyclone. High pressurized region will consider as anticyclone. Stable atmosphere. So air pollution is more. Air pollution is high. Second condition, low pressure. Because of passage or instability in the atmosphere, pressure is released out. Air masses have been passed. So due to that reason, pressure is released out. Temperature fall down. So ultimately unstable atmosphere is created. Low pressure, we can consider low pressure, unstable atmospheric condition. Due to that, air pollution is less. Air pollution is less. Again I am repeating. Under high pressure, pressure is there in atmosphere because there is no movement of free air. Wind masses are not circulating, not distributed. So pressure and temperature are high. So due to that reason, stability is more, air pollution is more. Suddenly wind mass came. What happened? Pressure in the atmosphere wiped out, released out. So temperature also fall down. Drastic changes in the atmospheric condition. That drastic changes in the atmosphere, unstable condition. So air pollution is said to be less. The last factor, humidity. Moisture content in the atmosphere, we call it as humidity. What the humidity will do? The moisture reacts with pollutant mass responsible for formation of secondary air pollutants in atmosphere. Humidity or moisture in the atmosphere. We have studied the secondary air pollutants. Smog, ozone, peroxyacetyl nitrate, all the secondary air pollutant, because of chemical reactions of, including acid rain, because of chemical reactions of primary air pollutants with atmospheric moisture or humidity, these secondary air pollutants are going to be caused. So these are the effects imparted due to various kinds of meteorological factors. We have studied temperature, pressure, wind velocity, humidity, effects, meteorological factors effects on air pollution. We are going to solve one numerical question. Clear? We are going to solve one numerical question. Elevation and temperature data for a place is tabulated below. Elevation 4 meters, temperature 21.25. Elevation 444 meter, temperature 15.70 degrees Celsius. Based on above data, lapse rate can be referred as, based on above data. So remember, the elevation or altitude which is near to the ground level, always take it as Z1. Don't take in the order given. The value of altitude near to 0 kilometer, near to ground level, that is Z1, and its temperature is taken as T1. The altitude farther from the ground level, that is Z2, and its temperature is T2. So what is the formula for lapse rate? Lapse rate, we have the formula dt by dz. dt by dz is equal to T2 minus T1 by Z2 minus Z1. dt by dz, T2 minus T1 by Z2 minus Z1. T2 15.70 minus T1 21.25 temperature divided by altitude Z2 444 minus 4. And a very important thing you need to remember here, this altitude values must be taken in kilometer, not in meters. What is given here? Given here is in meters, we need to convert to kilometer, multiply here with 10 power minus 3. So why we are multiplying with 10 power minus 3? Because converting meter to kilometer, converting for meter to kilometer. What is the answer you are getting? It is the value of lapse rate you are getting. Tell me. Value of lapse rate. Okay, answer is super ALR. We know it. Answer is super ALR. What is the value you are getting? T2 minus T1 by Z2 minus Z1. 15.70 minus 21.25 divided by 444 minus 4. Till that everyone will do. But multiplying with 10 power minus 3 to convert meter to kilometer, that is very important. Okay, Manoj, very good. Minus 13.875 degrees Celsius per 1 kilometer divided by total kilometers, total altitude we have taken. So minus 13.875 degrees Celsius dt by dz more than 10 kilometers, more than 10 degrees Celsius. dt by dz greater than minus 10 degrees Celsius per kilometer. So answer is super adiabatic lapse rate. The value of lapse rate greater than 10 degrees Celsius decline, we can consider it as a super ALR. Next one. An air parcel having 40 degrees Celsius temperature moves from ground level to 500 meter elevation in a dry air following ALR. Clearly mentioned. Dry air and ALR means This condition, dry adiabatic lapse rate, which we can say dt by dz is equal to minus 10 degrees Celsius per kilometer. Dry air, clearly mentioned, dry air. Then resulting temperature air parcel 500 meter elevation, means from here to here 0 meter to 500 meter. 500 meter means half kilometer it is completed, 0.5 kilometer. If it completed 1 kilometer, how much decline? For 1 kilometer decline is 10 degrees Celsius. For half kilometer decline is 5 degrees Celsius. So here it is 40 degrees, 35. Manoj is very fast. So at 0 meter 40 degrees, after 500 meters it is 35, after 1 kilometer it is 30. So we will take also like this, using formula, answer is 35. We also use the formula and solve the question also. We will take T2 is needed, T1 40 degrees Celsius, Z2 0.5 kilometer, Z1 0, both are in kilometers only, is equal to minus 10 degrees Celsius. So we'll get T2 is equal to 35 degrees Celsius. We'll get T2. Without formula, simple analysis, we will get it now. For 1 kilometer travel 10 degrees, half kilometer travel 5 degrees decline. 40 minus 5 degrees decline is 35 degrees Celsius final temperature. So again tomorrow same time 8:30 p.m. same YouTube live we are having the final part of air pollution part 7. We are discussing about air pollution control devices. What are the various equipments, treatment units used in the industries to reduce air pollutants in the atmosphere? So tomorrow's topic is air pollution control devices. We are discussing in same time, at the same time 8:30 p.m. in YouTube live. Same the last part of air pollution part 7 we'll discuss tomorrow. Not getting you making both. I am not going to discuss all these slides again and again, but I will tell you one thing. So these are the subjects taught by me in Unacademy: environmental engineering, hydrology, irrigation, open channel flow, construction materials. This is my friend, colleague who is going to teach you in Unacademy: transportation engineering, steel structure, structural analysis and RCC. And some of my friends also are coming and they will teach remaining subjects and will complete as a package of GATE ESC Civil Engineering. We will support you till you crack GATE examination. Very important thing, we don't dump unnecessary information and does not create any confusion. It should be clear to you. If you go through the air pollution concepts, you can understand how much clear you got the concept of air pollution. What is required for exam point of view only we discussed. We are not going to discuss unnecessary dump for you. Only we provide exam specific content that comes with vast experience in teaching GATE and ESC only. So don't confuse about anything. Believe the faculty, those who are giving exactly required specified content in clear and simple manner. So remember, live class means always live interactive sessions only, not recording sessions. Again I am repeating, Unacademy will provide you always live interactive sessions. It does not till lockdown, even after lockdown also you have live interactive sessions only. We never invite you to come for the physical classroom coaching. We never ask you to go recorded sessions after lockdown. Till lockdown you go for a live interactive session till we prepare recording sessions. No, not like that. Unacademy always unlimited access for live interactive sessions. If you miss the class, these live sessions are recorded, stored, saved. You go through it. but always we provide unlimited live interactive session. Remember, for Unacademy, live class, online class means live interacted only. It is not a recorded class. And if you take subscription in Unacademy using my code KPCIVIL and Engineering, you can use any code of the faculty or any code of the ad given by Unacademy management also. The common advantage, you are getting 10% discount. But along with that, I will provide you the best online test series platform for free. If you use my code KPCIVIL Engineering Guru, provide a free online test series to you. And regarding all subjects, complete pack of notes, soft copies I will forward you. Not only for civil, remember, for any branch student this is applicable. You spread it to your friends also. They will get the complete pack of their notes, scanned copies of their notes and other materials through mail if they enroll. They also, any branch of student will get online test series. Any branch of student will get soft copies of notes and other materials if they use my code. And I will support through the panel of experienced faculty accompanied with me. And also I will provide doubt clearance session in WhatsApp group, and also I will provide post-grade guidance. If you want support from me, join in my Telegram channel Engineering Guru. And before taking online class, just ask whether it is recorded live interactive session. Recorded till lockdown period or forever. Ask that one. That is very important. Think twice before joining the course. Most of the top civil engineering faculty in India are moving to Unacademy. Unacademy is the India's largest online learning platform. If any doubts related to you, text me 9704571767, my WhatsApp number. Okay, GATE special course is going to start early, so as early as possible subscribe for Unacademy course. Okay, good night for today. Again tomorrow we are meeting at the same time, 8:30, same on YouTube live. So until then, good night for today.